Welcome back. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. This is the AZ-400 exam prep video series, and in this third episode we will review how to design and implement build and release pipelines. In this group we will revisit how to design and implement a package management strategy, design and implement a testing strategy for pipelines, design and implement pipelines, design and implement deployments, design and implement infrastructure as code, and maintain pipelines. Some of these areas might show up on your exam or they might not. This list doesn't cover everything, but it gives you an idea of what to study. It's important to know what's on the exam and what's not so that you don't study something you don't need. We won't talk about all these topics in this episode. Some of them will be summarized later at the end. Having a package management system and process in place is one of the 4 pillars of continuous integration. Make sure that you understand the reason behind and the benefits of these 4 pillars. Keep in mind that one central component of such a package management system is a so-called package feed. For example, a project feed in Azure Artifacts or in GitHub packages. What features do each of these tools offer? And also bear in mind which package types each of them supports, since they are differences. For example, GitHub packages supports Docker images, while we would need to utilize Azure Container Registry for this when using Azure Artifacts. Consider also reasons to use a public feed over a private feed and vice versa. Know that packaging helps to identify, maintain, and manage software components with different life cycles and rates of change. Be aware that packages are immutable and any change requires a new version. Understand that versioning schemes vary per package type and express the compatibility and stability of a package. Remember that in Azure Artifacts, views can define quality levels without changing version numbers. By default, there are 3 different views. That is local, pre-release, and release. Be aware that the term promoting refers to the action of moving a package from one view to another. It is important to know that release gates are pre-deployment and post-deployment conditions that ensure the quality and reliability of the deployment pipeline. And this can be done by either entering or leaving a stage of a release pipeline. Understand that release gates can be used for checking for license violations, vulnerabilities, technical debt, compliance, and blocking issues. Have a solid understanding for the exam of the parts of an Azure pipeline, such as agent, artifact, job, pipeline, release, stage, trigger, and the others. Remember that code coverage helps you measure how much of your code is tested and improve your code quality. Recall the steps for implementing code coverage analysis. There's this YAML file to be changed in the root of the repo to configure the settings. And when configuring the settings, consider the difference between full coverage and diff coverage and how to set the target threshold. While Azure Pipelines uses agents, GitHub Actions uses runners. Same concept in general, same image, different name. An agent or runner is a software component that handles one job at a time. And you usually need at least one agent to execute your build or deployment tasks. Make sure you understand the different types of agents and runners. There's Microsoft hosted or GitHub hosted respectively, and self-hosted. Review what you get with each and when you should prefer one over the other. In that, also recall the network connectivity limitations when using an agent or runner behind your network firewall. How to solve a no line of sight scenario. What needs to be in place to make this work for you? Keep in mind that a release only uses a parallel job when it's actively deploying to a stage. Otherwise, it does not consume any parallel job resources. consider the options to increase the number of parallel jobs per organization. There are a few that depend on the project's visibility, if it's either public or private. Azure Pipelines has YAML and classic pipelines, but GitHub Actions uses only YAML. For the exam, notice how the setup and the parts of a GitHub Actions workflow are different or similar from those in Azure Pipelines. For example, one workflow has one or more jobs that use actions in their steps. Instead of release gates, you can use approval and checks in an environment, and be informed about some of the standard workflow keywords like on for a trigger, runs on for the runner image specification, uses for the action that you're using in that particular step, or run for any command line execution. Keep in mind what the steps are to configure YAML pipelines in Azure Pipelines. What are the benefits you get from keeping your pipeline definitions as code? It's important to know that you can modularize your YAML pipelines by using templates for stages, jobs, steps, and variables. Consider that with YAML pipelines, you don't have the classic buckets for build and release pipelines. Your YAML pipeline can be used to build and deploy, or just one of these actions, whatever you need it to be. What deployment patterns does your team want to implement? If you use feature toggles in your code, you have a variety of different modern deployment patterns available, like blue-green deployments, canary releases, or A/B testing. Pay attention to the differences between these and what use cases these are suited for. Are you targeting a subset of users, or do you want to experiment on a new configuration in the backend? Which one of these patterns could you prefer in which case? What ways do you have to ensure an order of deployments for patterns like this? Remember that YAML pipeline jobs by default run in parallel. So we would have these two jobs, startup and build. In this first example on the top right, we would have them run at the same time. But if we then use the keyword needs with configuring it for the job startup, that would mean that the build job will only run once the startup job has completed. Minimizing downtime during deployments is key for each DevOps team. Think about how you want to deploy your app for different stages like development, testing, staging, and production. They might need distinct settings, permissions, and dependencies. It is essential to have a plan for how to fix urgent bugs in your code. You should be able to deploy a quick fix to the environment that needs it without messing up your regular deployment process. Review the resiliency checklist for some services on Azure, such as app services, event hubs, and Azure Storage. You should make sure that your app can deal with failures, scale up or scale down, and recover from disasters. And these services would all help you out with some built-in features to prevent or minimize downtime. Infrastructure as code and configuration as code are concepts that enable every DevOps team to implement the modern deployment patterns we covered earlier. When you set up and deliver software applications by hand, it's slow and you can make mistakes. When you use code and scripts to do it, it's fast and reliable. You can also keep track of the changes, test them, and run them automatically in a proper way. In general, keep in mind one of the main goals of DevOps is to automate as much as possible and to reduce waiting time. Know that infrastructure as a code, or IAC, can be used to set up and manage your IT resources with code or scripts or templates instead of doing it by hand. Be aware of the two approaches for infrastructure as code, declarative and imperative. Declarative infrastructure as code describes the desired state of your infrastructure, while imperative infrastructure as code lists the commands to achieve that state. Remember that infrastructure as code should have the property of idempotence, which means that running the same code or script multiple times will always result in the same outcome. Idempotence ensures that your infrastructure is consistent and error-free. Remember that platform engineering is the practice of building and maintaining the environments where your apps run on with the right settings and policies. Keep in mind that platform engineering is a key part of DevOps, or can add to it because it enables you to automate and standardize your infrastructure and processes. In that, platform engineering goes beyond infrastructure as code, because it also involves designing and managing the platform as a product with a clear vision, a roadmap, and features that meet the needs of your customers and stakeholders. Be aware that the goal of platform engineering is to reduce but not limit the choices for developers to focus on the inner loop tasks. Make sure you understand that Azure Deployment Environments is a service that helps you automate and standardize your app infrastructure. It lets you define and manage environment templates, policies, and configurations, and enables developers to quickly spin up infrastructure using these templates. Review the other factors that can affect the cost, time, performance, and reliability of a pipeline. Refresh your memory on how to set retention policies for your pipelines. Note the different retention settings for pipeline artifacts, releases, and other components. Remember the steps for estimating parallel jobs. How do you figure out how many parallel jobs you need in your team? You need to understand that parallel jobs are bought at the organizational level and are shared by all projects. A bit out of context here, but familiarize yourself with the configuration options for agents in Azure pipelines. How does the agent authenticate? What options do you have? How can you configure startup options, and when is one better than the other? And how are agents updated and upgraded? Other skills in this group that I haven't covered include these ones here, and I will go from the top left to the right and then down. To select a deployment automation solution, including GitHub Actions and Azure Pipelines, make sure you know the comparison and contrast between GitHub Actions and Azure Pipelines in enough detail. When it comes to design and implement integration between GitHub repositories and Azure Pipelines, know how to integrate GitHub repositories and Azure Pipelines in both directions. Implement feature flags by using Azure App Configuration Feature Manager. This is about exploring how to use Azure App Configuration Feature Manager to implement feature flags in your code and make it work for your team. Implement application deployment by using containers, binaries, and scripts requires to either be or get acquainted with Docker files and how to deploy applications by using containers, binaries, and scripts using Azure Pipelines. Implement a deployment that includes database tasks. In this, you should know that the Azure SQL Database deployment task is the main tool to deploy a database to Azure. Remember that creating a data tier package or a DAC pack is the simplest way to deploy a database. And also consider that you could use instead SQL scripts of a DAC pack to deploy a database too. Monitor pipeline health, including failure rates, duration, and flaky tests. In this group, stay informed about your process and releases by leveraging release gates, events, subscriptions, notifications, service hooks, and reporting. Also know that actions in Azure DevOps trigger events, and that users can subscribe to these events and get notified by email. Migrate a pipeline from Classic to YAML in Azure Pipelines. Bear in mind the ways to migrate from Classic to YAML in Azure Pipelines. Create a sample or a template YAML pipeline and adjust it. view YAML snippets of a task and paste them into your existing pipeline. And third, export your classic build pipeline to YAML. In this episode, we revisited how to design and implement a package management strategy, a testing strategy for pipelines, deployments, infrastructure as code, and how to maintain pipelines. With that, we come to the end of episode 3. We hope you will join us for episode 4, Develop a Security and Compliance Plan.